Evaluate the square root of 5 squared. We know that when we're squaring something, we're multiplying it by itself. So this just means the square root of 5 times the square root of 5. Now, 5 times 5 is 25, so this gives us the square root of 25. But we know that the square root of 25 is 5, so our final answer here is 5. But we could have gotten that more quickly. If we look at the original problem, we start off with 5, and we're taking the square root of 5, but then we're squaring the result. And we've seen that taking a square root and squaring are, in a sense, reverse operations. So when we take the square root of something and then square it, squaring it effectively undoes the step where we took the square root. So in general, we have a rule. If we have the square root of some constant c, and that constant's not negative, we want this to be defined, and we square that, we end up with the constant that we originally started off with. So this is true if our constant is greater than or equal to 0. This is a nice rule. And then the same thing works if it's a higher power. If we have a cube root of something and then we cube it, so if we've got a cube root of a constant and we cube it, taking the cube root and cubing cancel each other out, and we are left with a constant. This doesn't require the constant to be non-negative, because we know we can take the cube root of a negative number. So this restriction that the constant is not negative only applies when we have an even indexed root. In general, though, it's good to know that squaring something and taking a square root, or cubing something and taking a cube root, usually end up canceling each other out, though sometimes there are some quirks, like dealing with negative numbers. These are things that will come up later and are useful.